For today's lesson, we are going to determine the necessary numbers of subatomic particles in an atom. These numbers are basically the number of protons, number of electrons, number of neutrons, atomic number, and mass number. Okay, but before we proceed to determining these numbers, we have to know the basic symbols that you have to be familiar with so that you won't be confused while determining the numbers. So for protons, we will use this sign P plus. Okay, so the script plus or positive there represents the charge of proton. So it means protons are positively charged. And we also have electrons, and its symbol will be E negative. The script negative is also representing the charge of electron, which is negative. And then we have neutrons, that's N 0. So the script is 0 because basically neutrons have no charge. And then for atomic number, we have Z as the symbol, and for mass number, A is the symbol. So what you see on your screen is basically the symbol of helium. Okay, so this symbol can be found on the periodic table of elements, and again this is helium. Okay, so the structure that you see here is basically the element notation of helium. Okay, now you see there two numbers, we have 4 and 2. Okay, so before we identify the numbers of subatomic particles, the mass number, and the atomic number of helium, let's first talk about the basic rules of determining the numbers. Okay, number one rule, mass number. Okay, so mass number is represented by, again, capital letter A. And for you to solve for mass number, you have to add the number of neutrons and the number of protons. Okay, so you just have to first identify the number of neutrons and protons, then you add them up and you will have the mass number. And for number 2, we also have the atomic number. Atomic number, and the symbol for that is Z. For you to get the atomic number, you just have to know the number of electrons. So basically, atomic number is equal to the number of electrons. Okay, and number 3 rule, you have to know that the number of protons is always assumed as equal to the number of electrons. Okay, so basically, the atomic number is equal to electron, or the atomic number is always equal to the number of electrons. Therefore, the atomic number is also equal to the number of protons. Now, let us use this notation in identifying the mass number and the atomic number. So, HE, you see there are two scripts. The first script is 4 and another script 2. Okay, so the script on the upper right, that is always your mass number, and your script below the mass number is basically the atomic number. You have to take note that there are other element notations wherein the scripts are structured differently. Sometimes the atomic number is above the symbol, sometimes it's below the symbol. On same thing with the mass number, sometimes it's below, sometimes it's on the left, sometimes it's on the right. Okay, but you just have to really know how to recognize which one is your atomic number, which one is your mass number. Okay, so class, for our first example, we have here the element notation of sodium. Sodium is represented by the symbol Na. And as you can see on your screen, you have two scripts. You have 23 and 11. So the task that we have to accomplish is to identify the five necessary numbers for this element notation. So you have Z, A, P plus, E negative, and N0. So again, let's recall the meaning of these symbols. So Z is for atomic number, A is for mass number, P plus is for protons, E negative is for electrons, and N0 is for neutrons. So first, let's talk about Z. Okay, for your Z or for your atomic number, um, according to our discussion earlier, atomic number is always the one that's below the upper script. So here, 11 is your atomic number. Therefore, it's very easy to identify the atomic number. You can just copy the number below the upper script, which is 11. Okay? And then for the mass number is always the one that is above your atomic number. So above 11, that's 23. So basically, your mass number is 23. And then for proton, no, we have discussed earlier that the number of proton is always equal to the number of electron. So the number that you will indicate here will be the same with the number that you will indicate here. So for you to get proton, you should first know the number of electron. Okay, so how are you going to know the number of electron? Okay, we also discussed earlier that atomic number, so this one, atomic number, is the same with your electrons or the number of electrons. So basically, they are equal. So if your atomic number is 11, therefore, your electron is also 11. And since we also said that electron is always equal to protons, or the number of electron is always equal to the number of protons, then the number of proton is also 11. Okay? And now, how are you going to determine the number of neutrons? So basically, we will just use the formula of mass number. So our formula for mass number is A is equal to P plus N0. So we already have our mass number, we already have our P plus or proton, that is 23, and your P plus is 11, and your N0 is unknown. So you can simply solve for your N0. N0 is equal to 23 minus 11. So 23 minus 11, N0 is equal to 12. Therefore, the number of neutrons will be 12. Okay, so for our next element notation, we have here the element notation of magnesium. So you have two scripts again. So basically, we will determine the same numbers. You have Z, A, P plus, E negative, and N0. How are you going to identify these numbers? First, let's go with Z. So basically, Z is the atomic number. So it's the one that's below the upper script, that's 12. Okay, and then your A, that's the upper script, that's 24. And your P plus, okay, again, we will do the same thing. We will first identify the number of electrons, and then that will be the same with the number of protons. So how are we going to get the number of electrons? It's just the same with the number of atomic, or it's just the same with the atomic number. So if your atomic number is 12, then your electron or the number of electrons will be also 12. And since the number of electrons is equal to the number of protons, then the number of protons will be 12 also. Now, how are you going to identify the number of neutrons? So we will use again the formula of mass number. Mass number is equal to number of neutrons plus number of protons. You already have your mass number in protons. Your mass number is 24, and your neutrons is unknown. The number of neutrons is unknown, plus the number of protons is 12. So basically, that is N0 is equal to 24 minus 12. Therefore, your neutrons or the number of neutrons will be also 12. Next, let's talk about calcium. So this is the element notation of calcium. So we have a script here 40 and another script 21. So we will be determining the same numbers. So first for your Z, that will be 21. And for your A or mass number, that's 40. For your P plus, first you identify your E plus. Your E plus is equal to your atomic number. So if it's 21, then you also indicate here 21. And then your P plus, since it's equal to your E negative, that is also 21. And for your neutrons, you can just solve for this orally, but let's just write it here. So that will be A is equal to neutron plus protons. Okay, so since we're looking for neutrons, then we can say neutrons is equal to A minus P plus or P positive. So your A is 40 and you subtract 21 from that because 21 is the number of protons and you will get 19. Therefore, the number of neutrons is 19. Let's have another example. For Si, we have silicon. Okay, this is the element notation of silicon. You have 28 and 14. So the same numbers, Za, P plus, E negative, and 0. How are we going to identify or determine these numbers? So for Z, you just have to copy 14 there because it's your atomic number, and above that is your mass number, so it's your A, 28. For your P plus, first you identify E negative. E negative is always the same with your atomic number, so your E negative is 14. And the number of electrons will always be equal to the number of protons, so this is also 14. And for you to solve for neutron or the number of neutrons, you use the formula neutrons is equal to a mass number minus your P plus or protons. Your mass number is 28 and your number of protons is 14. Therefore, N0 or the number of neutrons is also 14. Lastly, let's talk about the element notation of potassium, which is represented by letter K. So you have 39 and 19 as your scripts. So your Z, A, P plus, E negative, and N0, we have to get them or determine them. So for your Z we have 19, and for your A you have 39. For your P and E or P plus and E negative, that's also 19 because atomic number is 19, therefore your electron is also 19 and the number of protons is also 19. And then your neutrons or the number of neutrons will be determined by using the formula neutron is equal to A minus P plus. So your A is 39 minus 19, therefore your N0 is 20. For our last case, we have here a different format of a problem. So it's not expressed in an element notation. So by the way, our element here is neon, and the only given numbers are, first we have the mass number, and we also have the number of electrons. So using these given numbers, the first number that we can determine is basically your atomic number, because like what we have been saying, the number of electrons is always equal to your atomic number. So if your electrons or the number of electrons is 10, then your atomic number is also 10. And we also said that the number of electrons is always assumed as equal to the number of protons. So if you have 10 as your E negative, your P plus or P positive should also be 10. And then for your neutrons or N0, you can just get the number of neutrons by using this formula. A minus P plus. So your A is 20 minus your P plus is 10. Therefore, your neutrons will be 10. That's the number of neutrons.